We opened up in Charlotte about a year and a half ago, but are headquartered in Seattle and have offices all over the place. And we're hiring. So we are looking for folks to join our data and analytics practice. So if you're interested, please reach out to me. I have specialized in data warehousing, streaming systems, software engineering, cloud. I'm super interested in machine learning and hope to delve more into that, and have been trying to learn about it a little bit more in my free time. But these are some of the topics that I try to focus on in my work and in my free time. But enough about me. Let's talk about some more interesting things. So brief agenda. We're going to talk about some traditional data warehousing patterns that I hope you are all familiar with. I'm going to go into some of the shortcomings of those patterns, talk about a new-ish paradigm, and then go into a demo. And what I hope that you primarily take away from this presentation is less around the specific particular implementations of whatever technology we choose. What I'm really trying to drive here is showing this new paradigm, showing how we can plug and play different technologies into this architecture, and talk about where data engineering as a career is going and where we've been and what this transition has looked like. So with that, I'm going to start the presentation with a kind of a contextual concept. So imagine you are a data engineer. You've started working at some new company, and they have a fairly straightforward on-premise architecture. It might be running SQL Server. It could be Oracle. The particular implementation doesn't matter. But in this really simple use case, which I'm sure you have all interacted with some version of this, we have some application databases. These are just MySQL databases, not really under our control, but we bring that data over via some ETL process. Let's call it SQL Server Integration Services if we're working with SQL Server. We bring that over maybe a couple times daily into our SQL Server data warehouse. We model that data in a dimensional data model, and then we perhaps have some analysis services cubes that pre-aggregate that data, and then our end users will access it via Excel workbooks. So this was an extremely common pattern, albeit simplified to probably far beyond what actually any enterprise worked with. But I think it illustrates the point of a simple architecture that we can all understand. And in terms of kind of our health of our system, I want to track it using 3 metrics. So in terms of storage, we're not looking at a ton of storage. It's a little bit of application data. So we're definitely good on storage. We've got plenty in our on-prem data warehouse. Doesn't take up a ton of compute capacity. The aggregations that we're applying aren't that complex because we don't have a ton of data. There's not a lot of work to be done. And then our ETL is fairly straightforward. We have really just one ETL process to load in that application transaction data into our data warehouse. So things are moving along great with this architecture. But then we, as a company, start to grow and expand, and we have some new data sources to bring in. So we started integrating with Salesforce, and that complicates our architecture a little bit more. But again, nothing too complex. So here we need to set up another ETL pipeline to bring in that Salesforce data into our data warehouse. But all things considered, this doesn't significantly impact our architecture too much. So if we look back at our health metrics, our storage has increased. Salesforce is going to add a lot of data, but we're still feeling pretty comfortable in our system's capacity. Compute, again, that's going to increase as well. We have some more complex modeling to do to integrate our Salesforce data with our OLTP data. But again, it's nothing too wild. And then our ETL complexity has additionally increased because we now have 2 separate ETL processes to maintain. So things are running along fine with this, but all of a sudden, our company decides that we need to start ingesting some clickstream data. And if you've ever worked with clickstream data from the web, you will know that there's a lot of it to get value, and it can be complex to deal with. So we have our clickstream data coming in, which of course requires some ETL process. So now we've got 3 ETL processes We have a lot more data coming in. That clickstream data is really pushing our server to the limit. So if we look at our new health metrics, things are looking not so great. That clickstream data really pushes us over the edge as far as our storage goes. Our compute is barely keeping up, and our ETL complexity is high now. So we do what any good data engineers and database administrators would do, which is we decide to add another instance to a SQL Server cluster to help distribute that workload a little bit better. So this works. It gets us to a point where we're back in kind of that mid-range where our storage is not crucial, but still we need to be cautious of it. Same with compute and ETL complexity. But then the big one hits, and our company's featured on the front page of Hacker News. We get an influx of new users, and our clickstream data, our Salesforce data, our application data, it goes through the roof, and we can't keep up, and our on-premise architecture is hosed. So we've got some problems with this traditional on-premise architecture. Key among them is scalability. It's difficult to scale when you're dealing with things like web volume data, when you can't reliably predict the amount of traffic you're going to get. So it takes a lot of time to add new servers to that on-premise architecture. It takes a lot of man hours. It's a difficult task. Another key problem here is the separation of storage and compute. So these on-premise systems, they tightly couple the storage system in the data warehouse to compute. So for example, if your data volumes are increasing significantly, but your compute requirements are not, you still have to add more storage to that system and increase your compute capacity because of that tight coupling. So you can't have one without the other. And then finally, it can be difficult to deal with independent, isolated ETL systems that often have proprietary formats that aren't portable. So it's not easy to take, for example, an SSIS package and convert that to some other system. And they're often not very source control friendly because they're oftentimes point and click GUI based applications. And then there's scheduling and orchestration troubles that can come where you have a whole bunch of different systems that you're trying to independently orchestrate. So it's going to become a nightmare, and you spend pretty much all your time putting out fires. So what is the fix to this? And this is kind of a joking slide because, in the last 10 years, I think this has been said a lot that, hey, Hadoop is the answer to all our problems with our on-prem database. It's going to scale everything for us. It's going to do everything. But I think as we've seen in the last 10 years, Hadoop has not lived up to the promise that it's claimed to. So this is Google Trends chart showing interest of Hadoop over time. It's steadily decreasing. There's certainly implementations out there, but Hadoop as the answer has proven to not be the right answer to this. So that is the lazy answer that I think we as an industry decided that we could do better with. And that's what I'm going to show you today is how we can do better than constrained on-premise architectures, how we can do better than something like Hadoop, which while it served its job at certain places for a certain amount of time, I don't think that the patterns still apply today. So hopefully it doesn't come as any surprise that we can leverage cloud, and cloud can solve a lot of our problems. It of course gives us infinite, not quite infinite, but effectively infinite scalability. So if we need more servers, we can easily provision them in minutes. You don't have to order physical servers, rack and stack them, and deal with the weeks of time and the sometimes prohibitive cost that it takes to add more servers. Similar with storage. So you can use object storage, things like S3, and that is effectively limitless as well. Another key component here, which is going to be central to the topic today, is hybrid architectures. So you don't have to commit 100% to the cloud. You can use the cloud for the components that you want. Additionally, you don't have to commit 100% to one cloud. So you could use some services in AWS ecosystem, some services in the Azure ecosystem, some services in the GCP ecosystem. A lot of the core architectures are based on non-proprietary open source platforms that you can swap in and out. And APIs are exposed through these platforms that you can plug and play the architecture as you need to. And then finally, and I think this is a subtle yet extremely profound sentiment that I've seen in the last 5 or so years is, around 2014, 2015, people were claiming, Hadoop is the next big thing and NoSQL is going to overtake SQL. But what I've seen and what I imagine a lot of you have seen as well is that, SQL is still an incredibly reliable tool to do the job that we need to do. And it's proven to, over the last 40 years since its inception, be an extremely useful tool that has kind of proven the test of time. And while there are a lot of interesting things going on in the NoSQL world, for a lot of what we're doing, pure SQL is exactly what we need and what's going to work best for us. And it's what we already know. So we want to take the tools and concepts that we already know and apply them to these new architectures so that it is not a fundamental shift in our kind of thinking of the architecture. We still have some grounding in the architectures of the past. So with all that said, I'm going to try to make this a little bit more concrete and show you some examples of one particular implementation of an architecture that solves a lot of the problems that we discussed here. So hopefully some of these concepts are new. Hopefully maybe you have familiarity with similar tools or you've worked with it. But again, I encourage that you don't focus too much on the implementation of these tools. I'm going to have the repo publicly available for you to dig in because I'm not going to dive way too deep in all the code and every specific element of the architecture. I would say that that's probably an exercise that'd be great to do outside of this. For this, I think it'd be great to follow along, see how these things connect and get a high level understanding. So with that, we're going to go into kind of three main demonstrations here. So we have infrastructure as code, which is a concept that if you're not familiar with it, is a way to provision resources in the cloud using configuration files. So we don't have an administrator logging in point and click to provision everything for us. We have our architecture defined in a repeatable source control, ability to put it in source control kind of files. So I'll talk about that. And the particular implementation here is CloudFormation. Then we're going to orchestrate some ETL processes using Apache Airflow, which is a really interesting tool. And we're going to run that orchestration process on AWS infrastructure. And then finally, we're going to show how that ETL process can manipulate and load data into a Snowflake data warehouse. So got a lot to go over, so let's get started. So I'm in the AWS console, and I'm going to go into the CloudFormation tab. And you'll see here we have this concept called stacks. A stack is just a kind of discrete set of components that are deployed as a single unit. So I already have VPC, which if you're not familiar with the AWS vernacular of VPC, it stands for Virtual Private Cloud. It's basically just the networking components required to spin up some other architecture. And the CloudFormation script to provision this is also included in the repo if you want to take a look at that. So I have this already spun up, but I'm going to show you in the repository what the script looks like that we're going to be deploying. So again, I'm not going to go into excruciating detail on this because it's a couple hundred lines long, but basically it's a YAML file that defines some information about the resources we're going to be deploying. So what's great about this is we have a deterministic manifest that outlines all the components in our architecture, which is great. We can check this into source control. If we need to tear down our architecture and spin it back up again, we can do it knowing that all the components are going to come back up exactly as they were. So configuration as code is kind of pattern, the first kind of framework or pattern that I would encourage you to look into if you haven't done so already. So we have a bunch of things that are going to get spun up here, which I'll describe as we're doing that. But this takes about 10 to 15 minutes to actually run. So I'm going to kick that off and then go into a little bit more description describing what's happening here. So to provision this CloudFormation stack, I'm going to click Create Stack with New Resources. And we have a couple options. So you can specify your template via a file that you upload via an S3 URL, which I have this stack in an S3 bucket of mine. So I'm just going to specify that URL there and click Next. And then it gives us, prompts us for some options. So what should we name our stack? So this is going to be my Airflow. And it's running on ECS, which I'll talk about momentarily. And these parameters here, these are custom parameters that I have defined in this stack. So I'm saying whenever somebody spins up this stack, you need to provide it with some additional information so that it knows what work to do. So first one is the IP address range. So when we run Apache Airflow on ECS, we need to allow inbound traffic. So for now, and big red letters here, don't do this in production. I'm just going to allow access from everywhere. Again, don't actually do this in a production setting, because then everybody will have access to your application. We have some pre-populated parameters here. These pertain to the container configurations. So Apache Airflow is going to be running as a Docker container. So we have to specify how much CPU and memory to allocate to that container when it's running. We additionally want to specify which port to expose on our container. And then we want to specify down here our Snowflake account ID. So I have in this tab open my Snowflake interface, which we'll get into in a minute, but I'm going to pull the account ID from the URL. And you can sign up for a free trial of Snowflake. You get 30 days to experiment with it. So I encourage you to do that. The region of my Snowflake account is in US East 1. And then finally, it needs to know which stack was used to provision my VPC, because it's going to use some resources from that. So I'm going to tell it that I use the demo VPC stack. Now we have some kind of boilerplate options here. We can add some tags to specify properties of the resource that we're deploying. So this can be really useful to allocate, for example, specify the department or the owner or an email address so that your resources have metadata on them that you can search for. But we're going to skip over this. We don't need to add anything extra. And then finally, it gives us a page where we can review everything that we told it to do. And I feel comfortable with this. So I'm going to click Create Stack. Now it's going to go through, and based off of all the resources defined in that CloudFormation script, it's going to spin them up one by one. So going back to this presentation while we wait for that to run, let's talk about what's actually being provisioned here and then go over some of the possibly new terms or technologies that you haven't been exposed to. So this is a high-level architecture diagram of what we're deploying. So on the left, we already went over CloudFormation. That is the tool that is allowing us to provision our resources using this configuration as code. Systems Manager is a tool within the AWS ecosystem that allows you to store certain parameters. So we're storing the username and password for Airflow, or rather for Snowflake, in parameter store, among some other properties. So it's just a easily accessible key value store within AWS. So that's what is doing the deployment for us. And then within our VPC, this top box here, we are in a public subnet deploying a service called ECS. So ECS stands for Elastic Container Service. And all it is a serverless tool that you can use to run Docker containers. And Docker containers are fantastic. They're a great way to deploy applications. So that's what we're doing here. We have defined a Docker container that has Apache Airflow pre-installed. So that's gonna make it really easy for us to test our application locally if we have Docker running locally, and then deploy it up to Elastic Container Service. So AWS Fargate is just the serverless component of Elastic Container Service. If you want, you can provision your own EC2 instances for your containers to run on, but I'd would recommend the serverless model because it's going to be less maintenance and less overhead. Apache Airflow requires a database for it to store its metadata. So we are spinning up an RDS instance. RDS is Amazon's managed relational database service. So you can, in RDS, spin up databases. You can do MySQL, Postgres. I think you can do SQL Server. We're just doing a small Postgres database here because it's small and just storing some metadata. So our Docker container running Airflow, it's going to connect to that RDS instance running the Airflow metadata database. And that's how our ETL orchestration is going to run within AWS. Down here, we have the Snowflake infrastructure. Now, Snowflake will run in AWS. I believe it'll run in Azure as well. Don't quote me on that, but I believe you can do multi-cloud with Snowflake. Anyways, Snowflake is a completely cloud-based data warehouse environment that has a lot of the attributes that we look for in a modern data warehousing solution. So it separates storage and compute. It's scalable. It's cloud first. So we can do an entire day talking about Snowflake, but for now, we can move on and just talk about some of the core concepts and go into the demonstration. So talking about core concept, first is the compute and storage layers are completely separate and independently scalable. So Snowflake under the covers will store data in an optimized columnar format that is compressed. So it's going to be similar to your other columnar data warehouses like Redshift or BigQuery, or I believe Synapse Analytics will do this as well for Azure Data Warehouse, where it stores data in a columnar fashion, which is advantageous for analytical workloads. So the beauty of separating the storage and compute layer is that one, your storage can scale independently of compute. So you could store terabytes or petabytes of data, but if you don't really need to do much processing on that data, you don't have to spend inordinate amounts of money on the processing of that. Now, Snowflake has this concept called a virtual warehouse, which I don't think is a very good name for it, because to me, warehouse implies storage. But in this context, a virtual warehouse describes the compute resources. So virtual warehouse is this independent cluster of compute resources. So when you run operations in Snowflake that would require compute, things like select queries, deletes, inserts, updates, you have to have a virtual warehouse running. And you can configure the size of your virtual warehouse depending on the requirements of your workload. So if you have a really small workload that's not going to require massive compute power, you can spin up a really small warehouse, leave it running for the hour or so that you need to run your workload, and then spin it down. And you're only going to pay for that amount of time that warehouse was running. Additionally, multiple concurrent warehouses can run and query the same data at the same time. So this is one of the advantages of kind of this architecture where compute and storage are separate, is that these warehouses, they're all hitting the same object storage under the covers. So you could, for example, have one workload running, which is your ETL workload that requires significant compute. So you have a warehouse dedicated to that workload. And you can, of course, set permissions so that not just anybody can use that warehouse to run their queries. So it's a great way to kind of federate the use of resources in your data warehouse and control costs. Another core concept is loading data. So Snowflake provides some great utilities for loading all sorts of data formats, CSV, JSON, Parquet. And the pattern that you apply when loading data is generally 2 steps. So you upload files to a Snowflake accessible storage location. That can generally be any cloud object storage, S3, I believe Azure Blob Storage would work. And then you load data from those staging files into a table. Now, this is the approach that you would use for kind of batch loads. However, there is a component of Snowflake called Snowpipe, which is a persistent data loading mechanism where you are not charged as much as you would be if you did kind of the standard data loading using that ad hoc approach. We're not going to go into Snowpipe now. That is beyond the scope of this talk, but just wanted to make you aware that there are alternative ways to load data into Snowflake. So let's talk a little bit about Airflow. If you're not familiar with Airflow, it is a Python-based workflow orchestration engine. So I've talked about it as an ETL tool, but really it's more than that. It is a workflow engine. So you can write any really Python code or have any job that requires some kind of directed sequence of events that have dependencies on each other to run. But Airflow is kind of built for the data engineering workloads. So it has native database integrations with Redshift, BigQuery, Snowflake, MySQL, SQL Server, big data integrations with things like EMR, Spark, Databricks. So it has all these great plugins that make it really easy to create these kind of data-focused workloads and orchestrate them. So advantages of Airflow, it's got, like I just mentioned, all these fantastic integrations. I think the greatest advantage is that it's pure code-based, so it's all Python. So one of the disadvantages of the legacy architecture that we reviewed in the beginning was that they often rely on these legacy ETL processes that are, GUI based and proprietary, but Airflow is open source. It's written in Python. All your workflows are written in Python. So it makes it easy to put into source control, collaborate with others. It's portable. If you want to run Airflow in AWS, you can do that. You can run Airflow in GCP. You can run it on your own server if you'd like. It is completely portable. And then, like I mentioned, it's open source software, which I definitely prefer to use open source software in cases like this. Finally, the last new term we'll go over, which I talked about a little bit, is ECS, which is Elastic Container Service. So we've got Airflow. Airflow is awesome. We have it in a container, but it needs to run somewhere. We need a server for it to run on. And ECS provides that for us. ECS is a managed service for running containerized applications. So it is quote unquote serverless using the Fargate model, which means we don't need to deal with provisioning and operating our EC2 instances. However, if you want to manage your EC2 instances, you have a use case that requires that, you can absolutely bring your own EC2 instances there. ECS is tangentially related to Kubernetes. So in an alternate universe, we could do this exact same thing, but run our Airflow container on Kubernetes. Generally the same concept. It's just an orchestration platform for running containerized applications. So let's step back from these slides a little bit. Let's check on the progress of our stack. So our stack is complete. That's fantastic. But we still have a little bit of work to do before we run everything. So the first thing we're going to do is do some setup in Snowflake. And this repository, which again, I will provide the link to so that you can play with this as much as you like in your free time. It has some scripts that we'll use to kind of configure everything for this demonstration. So the first script is going to deploy some objects. So I'll copy that in there. Just real briefly talk about what's going on. So I talked about how we load data into these stages. So we're going to create some stages pointed to an S3 location that has some public data sets that we're going to work with. So here are the two stages we're creating that contain the data that we want. These are S3 buckets. This first one contains, I think they're JSON files, and the second one contains CSV files. And then we are going to create some raw tables that we're going to load the data into. So you can run all this right in the browser. And I got a failure. Okay. So I actually ran this earlier when I was doing some testing, so I think we're okay. I think there's just a collision on an object that already exists. So we're going to cross our fingers and hope that that's the case. But what we did do is created a user just to run the ETL process. So as you can see up here, I'm the sysadmin. You generally don't want to have your sysadmin be the service account for everything. So we're going to log out there and log in with Snowflake user. And we're now logged into a separate user account. We're going to deploy a couple more things. Oh, you know what? I ran the wrong script. So let me just go back for continuity. The script we actually need to run is the script to create our databases and create our roles and everything. So let's go ahead and run that. So that's going to create a database for our raw data. It's going to create a database for our analytics data. We're going to model out. It's going to create some roles, just doing kind of this admin stuff. I'm not going to go through line by line here, but I will point out, we talked about these virtual warehouses. So here's the DDL to create one of those virtual warehouses. So we're going to create a medium warehouse, and we're going to create an extra small warehouse as well. And then we created a user, Snowflake user. We will log out of my user, log in the Snowflake user. It's going to prompt us to change the password. And I'm going to use the password that I've configured in my Amazon parameter store so that Airflow knows how to connect. And now we are logged in as our service account user for the ETL process. And now we can run the script that I mistakenly tried to run before, which caused our error, which is where we need to create our stages and create our raw data tables that we're going to load into. So I'm going to go ahead and run this script. And it completed successfully. It's great. So we've got everything staged to start loading data into our Snowflake data warehouse. So I'm going to go back into AWS, and we're going to go to ECS. And ECS is our container service where we go in, and we have here a cluster. So in ECS, you have to create a cluster to run your containers. So we have this cluster, which was created by our CloudFormation script. We then have a service. Our service is called Airflow-ECS, and a service can contain one or more running containers. So ours is fairly simple in that we just have this single running container task, but in many application workloads, less so in the data engineering space, and more so if you have a microservice that might be composed of, or several microservices rather, that create an application. You would have them all running within the same service on the same cluster, and they could communicate between one another. But our use case is simple, and we just have this one running task, and you can kind of consider this task as a running container in ECS. So we'll click on that. We get some status here, which is great. It is in a running state, which is what we want. We have some properties that describe our task definition, which is what we deployed when we ran our CloudFormation scripts. I'm not going to go into all that right now. I'm just going to look at this container. It's great. So we can have some details just around all our properties. But the important thing we want to look at is this public IP address, because this public IP address now is how we're going to access the Airflow interface. So I'm going to go in here, and we have Airflow running in a container. Airflow gives us this really nice user interface that allows us to see our DAGs. A DAG in Airflow is a directed acyclic graph. It's really just an application that describes a data flow. So we have two in here. We have Snowflake Raw and Snowflake Analytics. And I'll go ahead and show you what the code looks like to kind of demystify that. So our Snowflake Analytics DAG, it's actually really simple. It's just a little over 50 lines of code. And all we do is we define our DAG, give it a name, give it a description, provide a schedule. And then we add some operators. So these operators are, you can think of them as the actions we need to execute. And we have 3 Snowflake operators. So like I mentioned, Snowflake, among many other cloud data warehouses, is a first-class citizen within Airflow. So we can provide these operators that tell Snowflake or rather tell Airflow what it needs to do within Snowflake. So the important thing to look at here is we are executing a SQL script. So again, SQL is king. We love SQL. So we just want to keep things SQL and not use any funky proprietary language or some funny NoSQL syntax. I like SQL, so let's stick with that. So the SQL script that we're going to run is specified there. We have some other properties here, the connection ID that we're going to use, what warehouse we want to use. So that's that virtual warehouse. So we're using our loading warehouse, the database, etc. And then finally, down here, we take these operators and we define the dependencies between them. So this says that first operator runs, then the second operator runs, and then the third operator runs. So this is effectively our directed acyclic graph, or our DAG. And if you're familiar with Spark, you should be familiar kind of with the concept of a DAG, but I won't belabor that point anymore. I will get to the fun stuff that I hope works. I'm going to turn on this DAG for our Snowflake raw load. And I can refresh here. And right now we have kind of these statuses here. So we have 2 operations queued, and we can continually refresh to check the status of what's going on. So we have 2 things running here. So if I click on that, it'll provide some information about what's running. I can look at logs, I can do a whole lot. I like to generally just stick to this main page and see what's going on. But so far, things are still running, which is great. And then we can go into Snowflake. And Snowflake has this really cool history feature, which allows us to see what queries have run, what queries are currently running, how long they took to run, what warehouse was used to run them. So really powerful metadata that we can use that a database administrator will love. So we can refresh this, and we can see now that we have this copy command running. So this is copying into our airline raw table. And if you remember, when we looked at our DAG, it was just running SQL. So let's take a look in here. There we go. There's the command that's running right now. So again, nothing too magical going on here. We just have a SQL command running, and Airflow is what has orchestrated that command to run. And it is loading our airline_raw table. So that's great. That's going to take probably a few minutes to run. It's, I think, 20 gigs of data. It's not a trivial amount of data, but it's maybe 20 million rows or 100 million rows. I forget the exact metrics on it, but we can let that run, and we can go into Airflow and refresh our status here. So you can see we have 3 successful tasks that ran. So these, we can look at that task. We can, do all kinds of things. We can look at the log that was executed. So we have complete visibility into what happened in our task run. Admittedly, Airflow has a slightly steep learning curve as far as navigating the user interface and understanding how scheduling works. It's slightly confusing and not the most intuitive thing in the world. There is a really good Udemy course that goes in depth into Airflow that I can provide the information for if you're interested in learning more. Airflow is actually a tool that was created by this guy, Maxime Bouchem. I don't know the exact pronunciation, but he built it while at Airbnb, hence the name Airflow, Airbnb. So he was a data engineer at Airbnb who built this. He's not at Airbnb anymore, but he's worked at Airbnb, Facebook. He's got some really incredible content and some cool ideas around kind of the future of data engineering and data engineering workloads, which is definitely a motivation for a lot of this presentation and a lot of the work that I'm currently doing. So things are still looking good. We still have our kind of raw copy operations running. And if we look what we're going to run next, once that's complete, is this Snowflake Analytics. So let's go ahead and take a look at this DAG. This should look fairly familiar. Looks a lot like the Snowflake raw DAG. Or actually, we already looked at the analytics DAG. The raw DAG is what we're running now. So apologies there, messed up my DAGs, but yep, this is going to run some analytical queries. So it's going to run the create analytics calendar, which is really just kind of creating a dimension table for us with some information, some data information that we can use. And then it's going to run the like an aggregation on the analytics airline and NYC taxi data set. So these are the operators we're working with. Again, you can do quite a bit with Airflow. And let's go ahead and check back at how our data is running. So looks like our NYC taxi raw has been loaded. So let's go ahead and just take a quick look at that. And if we refresh here, look at our raw public, we should see airline raw and NYC taxi raw, of course. Oh, and a note about Snowflake, I am doing this all through their browser interface, which is actually a pretty solid interface as far as browser interfaces go and browser IDEs go. But you, of course, have the ability to connect using data grip or kind of any of the JDBC compliance database IDEs. So you are not constrained to just running this in the browser. You can run this, you can connect to it as you would to Redshift, BigQuery. Obviously, you can't use SQL Server Management Studio, but there are other options. They also have a command line utility for running some administrative and operational commands within Airflow. So a lot of ways to run the commands and to set up automation workflows. But let's go ahead and take a look at this data. So here's our raw data. I'm only going to select the top 10 rows because there are around 100 million. But we loaded our raw data and we took some metadata about it. So we say, here's the record, here's the file name from that record. So this could be really useful for a data lineage strategy. It's always great to, in your downstream dimensional models, to be able to trace back a record to the exact immutable source from which it was derived. So that's one feature I really like of Snowflake is when you load data, you're provided with a lot of great metadata that can really help to assist in a strong data lineage strategy. You have obviously the row number that record came from in the source file. We hard coded this create process. You could obviously put whatever you want there, and then the create timestamp. So when was this data loaded? And then of course, most importantly, you have the source data. So we can look at this and see that we've loaded JSON in here. And that's another great feature of Snowflake is that you can query nested data, you can query JSON, you can query CSVs. It's very flexible in the data formats that it supports. And in our SQL command to query what is this? This is the airline data. So in our airline query, you can see here that we already ran that. Here we go. So here's how we can actually extract the fields from that airline raw data. So just pull out from the source kind of the field name, cast it to the appropriate type. So you have a lot of flexibility in how you manage that. Let's take a look at the taxi data just for completion. This is going to look slightly different because we loaded from CSV. So it already, when we provided the CSV load format, it delimited appropriately our data into these columns. So we have kind of all the raw data there, but we still, of course, have our source file name, our source file row, so we can get that really nice data lineage that we want. So there's our data, our raw data that's been loaded. Let's refresh this and see that everything's completed running, which is great. So we can go back to Airflow, can kick off our analytics job, which won't take quite as long, but that's just going to run these queries that are loading our airline table, calendar table, etc. So similar to our first DAG that we ran, we can see that we've got already one successful task that ran. If we look at our DAG, we can go in and view it in a different way. So this kind of, hopefully that's not too hard to see, but this shows us a graphical representation of our DAG. So we have this create analytics calendar date node, which we click on that, it'll expand and tell us information. And then these kind of next nodes in the DAG, which describe the operations that are going to run. So just a nice kind of visual representation. And you can see you'll get this chart filled out with the statistics around the DAG runs. So there's a lot of power in this UI, and it can definitely take some getting used to, but it's pretty great. So that's running. And again, we can go back to our history tab in here and refresh, and we can see that created our NYC taxi data table. We created our airline table, and we created our calendar date table. So everything is done in here. So if we go back to Airflow and we refresh, we have 3 successfully completed tasks, which is fantastic. So we can finally, after all that hard work, go in, take a look at our analytics database, look in our public schema, and see we've got our airline table, our calendar date table, and our NYC taxi table. So let's just select top 10 from, let's do airline actually, because that's the one that was nested JSON, just so we can see. There we go. So here we go. Our data has been flattened, removed from that JSON. Then we can go on and model this in any way we want and then further downstream processes. But at this point, our data is in the database. Airflow has accomplished this job of orchestrating loading data into our data warehouse. You can certainly configure Airflow to run your kind of further downstream transformations to take this raw data and transform it into a data model. Another tool that is really great for that I've been really interested in lately is called dbt. If you have not heard of dbt, definitely check that out. It's one of the more exciting products in the analytics engineering work industry that I've come across, and it's presents a really cool way to kind of build analytical models and ETL processes. But I'm not going to get ahead of myself. We already have enough technologies that we're focusing on today. So to recap, we've done a ton. There's a lot of work that went into this, and we've done some really cool stuff here. But to zoom back out from the details, we've taken Airflow, which is an orchestration tool, wrapped that in a container, and we can see down here, here's the Docker file for that container. So no magic here. We've just it's a pretty short Docker file. We're just installing Airflow in an Amazon Linux image. And we can run this container anywhere we want. We can run this container locally, which is great for testing. That's one of the benefits of Docker. And we can be confident that if it works as we expect locally in Docker, it's probably going to work as expected when we run it on ECS or Kubernetes, because those environments, that's kind of the point of containers, which is great. So we've got Airflow running in a container. It's running on ECS, which is our serverless container runtime engine. So Amazon has our networking infrastructure to run all that, and we can navigate to our Airflow UI through there. Then we talked about Snowflake, which is a cloud-first data warehouse that has some key advantages, such as separation of compute from storage, elastic scalability of storage and compute, a nice web-based UI, integration with Airflow. So a lot of great things there. So that pretty much concludes the demonstration. And again, there's a ton that we went over here. there's a lot, and I could have spent, several days going into the nitty-gritty details on all of this. Again, like I mentioned, I'll definitely provide this repository here. And we have in that repository, there are some good instructions for how to run all of this and how to configure it all. This is all based on a project that myself and a few other data engineers at Slalom started working on last year. We presented a lot of this at a Amazon Web Services demo day. So there's definitely, I don't want to take even half the credit for all this great work. There's some really talented folks at Slalom who put in a ton of legwork for this that I can just kind of stand on their shoulders and show a lot of this off. So hopefully this was a useful and engaging presentation for you. I hope that, if you have not explored some of these tools in the AWS ecosystem or Snowflake or some of the more modern paradigms of orchestration and ETL like Airflow, that maybe you can use this as a starting off point. I'm happy to field any immediate questions right now. I'll also provide my contact information, and please reach out to me at any time with questions that you have around this, or just kind of any related topic. I'd be more than happy to kind of engage and jump on a call and talk through any of this. And if you want to work on getting this running locally and running to issues, hit me up. We'll jump on a Zoom call and get it running. So with that, I will stop sharing and open the floor to any questions.
So I think Michelle was going to monitor chat. Was that happening? Okay. Maybe Michelle's on mute or something.
Yeah, so I see a...
I'm here, yep.
So I see a couple... And so do you use YAML template or AWS CDK for CFN? I'm using a YAML template. So in this repo that I'll provide, we've got these YAML files here. CloudFormation, you can configure the files using YAML or JSON, so whatever one you are most comfortable with. Any concerns or issues regarding the Snowflake database, like the cost of something else you came across during the project? That's a great question. And this is huge and definitely one of the main considerations that you should focus on before you implement any cloud solution, is that it is the learning, or the kind of the stepping off point is very easy to get involved in AWS or any of these cloud services. And you can start to run a whole bunch of applications and data warehouses, and then at the end of the month see a really nice fat bill that you weren't expecting. So with Snowflake specifically, again, there's, let's just talk about, if you're just running this in a demonstration environment, you have a free trial account. So you can run that for 30 days. So everything I can do that I did today in Snowflake is totally free. In Amazon, a lot of it's going to fall under the free tier if you haven't used AWS before. So you sign up for an account and you're eligible for a year of not entirely free everything, but there are services that fall under that free tier. So just to run this demonstration doesn't cost really anything. But if you're running in production, of course, with Snowflake, I've never actually run Snowflake in production, so I've only used it in demonstration purposes. However, I've worked with other cloud data warehouses like Redshift, and there my advice would be, monitor your costs really closely, set up alerts, set up budgets. Most major cloud platforms, I know Amazon does, at least, and I'm sure Snowflake has this ability in some way for you to set up budgets and notifications and alerts around your cost for the month. So costing all this out could be a whole nother presentation, so I won't go into that too deeply. But there are great options there. And one of the beauties of something like Snowflake is you can get your feet wet with it without spending thousands of dollars. You can provision some small workloads and some small virtual data warehouses and see how it fits into your workload and scale up from there if needed. All right. Another question was Airflow versus step functions. Any comments? Yeah, that's a really great question. So if you're not familiar with step functions are an Amazon service that is effectively allows you to orchestrate certain kind of activity within Amazon. So you can use step functions for, a lot of what we just did Airflow for. You can execute scripts using step functions. It's kind of a generalized interface for creating workflows. And I would say that I would prefer Airflow mostly because you avoid some vendor lock-in. Now, you're gonna have to weigh your trade-offs. So if vendor lock-in is more important to you, then definitely look at Airflow. Now, if on the alternative, what's more important is kind of the overhead it takes to manage. So as we saw with Airflow, if you're running in AWS, for example, you've got to spin up a little bit of infrastructure. It's serverless and it's simple to do, but there's a non-negligible both monetary cost and kind of technological cost to provision that. So I'd say really it's what's important to you is kind of the ease of step functions being totally serverless, and you can spin that up, pretty instantly, or use Airflow where you are you have maybe more control and more configuration, and it's a little bit more open, but more to manage. So again, what kind of a classic trade-off in this is of really any kind of serverless versus server-based solution is vendor lock-in versus technical overhead and complexity. But step functions are really cool. I think there are a ton of use cases for them. And I don't think it's totally necessary that you use exclusively step functions or exclusively Airflow. I think depending on your use case, step function might be the right tool for the job. If it's something really simple, you're just running one script, Airflow is probably overboard. So that's my thoughts on that.
All right, thank you so much, Wes. We really appreciate what you've presented. It was highly educative, and I definitely will make use of your materials. And thank you everyone for attending our online meeting. Would also like some feedback. If there are other ways we can improve this, we'll be glad to hear from you. If you would like to present as well, please feel free to reach out to any of us. You can reach out to me, Moyosori Lawal. You can reach out on LinkedIn or send an email to the group, or to Brad, or to Michelle. Okay. Thank you once again, and we hope to see you in July. Yeah, July 7. That's it. Thanks again, Wes. Everybody,
thank you.
Good evening.
Yeah, thank you. Yep, I just posted the information to the chat, and I can also distribute that to you, Moyo, and we can get that communicated for people who didn't catch it. But thank you.